Yep, so only about 20 minutes, yeah, screen time. So hi guys, so we did say that last time, isotopes. Isotopes are different atoms of the same element. So they just have the same number of protons because they are the same element, but then they have different number of neutrons. So the nucleus composition is different. So the nucleus composition consists of the nucleons, which are the protons and the neutrons, such that you have different nucleon or the mass number. So what would be different would be just your mass number or your nucleon number. But the most important thing is isotopes have the same chemical properties because they have the same number of electrons, and also therefore they have the same electronic configuration. So for instance, if you have carbon 12, the electronic configuration would be 2,4. And then this is versus carbon 14, where the electronic configuration is also 2,4 because both of them, they are different atoms of the same element. They have the same number of protons, which is 6 and 6, as you could get from your periodic table. Even though they have different number of neutrons, 12 minus 6 is 6 neutrons, 14 minus 6 is 8 neutrons, but your number of electrons is the same as the number of protons because you have atoms. So whenever you have atoms, the number of protons equal to the number of electrons there. If you have the same number of electrons, which is 6 and 6, for both isotopes, you must have the same electronic configuration, as simple as that, okay? So we're just gonna go through a couple of questions really. So in this first one, you have carbon 14 and carbon 12. Which statement about this isotope is correct? So I was just marking some work 4 for the multiple choice question because the other class, 9 Science 2, they started with work 4 instead of work 3. They didn't have the opportunity to do the calculation of the relative atomic mass yet. So they started with the MCQ. I realized that when people do MCQ, they just like to circle the answer. There was one student in 9 Science 2, did every question and got 0. Can you believe the chances of doing every single MCQ and getting 0? Okay, getting 0 is not a, it's like 1 in a million chance, okay? So that means that person doesn't know what he or she was doing, okay? Be very careful when you do MCQ, right? I think I already relayed to you the important skills when you do questions. It's not just about knowledge, it's about reading, and therefore you have to remind yourself when you read, okay? Which statement is correct? Which statement is correct, okay? Now the first thing here is, you will see A and B are together because if you look at the questions, the options are more reactive and more reactive. Whereas part C and part D, it says similar reaction, similar reactions, okay? So this first option is saying that this isotope number 12 is more reactive than isotope 14 because it has lesser mass. The reactivity there refers to chemical reactivity, but then what did we just learn about isotope just now? They have the same number of electrons. If they have the same number of electrons, they have the same electronic configuration. So both of these factors would tell you that they have the same chemical reactivity. This is the most important thing, yeah? So physically, they might be different, but chemically, they must behave the same way because they have the same number of electrons and they have the same electronic configuration as a result. So more reactive there is definitely wrong, which is why you can cross A and B out. In terms of similar chemical reactivity, you also need to identify the correct reason for this, okay? For part D, for option D, it says that you have the same number of protons. That's why you have same chemical reactivity. That is wrong because chemical reactivity is to do with your electrons. Your electrons are in the shells, so to do with electrons. In fact, is to do with the valence electron, where you can find out how many valence electron an atom has by looking at its group number. Group 1 would have 1 valence electron, group 2 will have 2 valence electron, group 5 will have 5 valence electron, so on and so forth. So I think you should know that the answer comes down to option C there. Are you guys okay? Okay, all right, let's continue. Question number 2. These kind of questions are very common in MCQ, yeah? So like I said, the other class didn't do very well because they were just picking the options. I think I've taught everyone to actually write down some stuff, right? Okay. So for option A, the first thing you should do with this kind of questions, they want the same number of neutrons. I think Rahiman had a problem with spelling nucleon versus neutron versus nucleus. Be very careful of the spelling. This is the center of an atom. Inside the center, you have the nucleons, which consists of protons and also neutrons. So what you do really is, well, we want the neutrons, but we can get from periodic table, proton number 5, proton number 6 there. So what you're going to get is you will get 11 minus 5 for the neutron, which is 6, 12 minus 6, which is 6. You want the same number of neutrons instead of doing for A, B, C, and D. So what I could do is I could simply just do for 1, the first one first. And when I get the answer, I move on. In a multiple choice question in an exam, you try and get the answer. When you get the answer, you move on. But make sure whatever you do, you get the correct answer before you move on, so we don't waste time to go through the rest. But for your practice, I guess, it might be quite nice for you to actually work through the number of neutrons for each one, and you can convince yourself that they will be different, okay? Now, part 3, question 3. This looks a bit tricky. It's just anneal pentium. It's an artificial element. One of its isotopes. So what we know about isotopes is different atoms of the same element. So it's the same number of protons, but different number of neutrons. These are things which you have running in your mind as you go through this question. As you see this word isotopes, you are reminded of the definition. This is something that you have in your mind, in your head playing, yeah? Okay, so which of the following is correct? They want a positive statement. This thing is a nucleon number 105. We know the number on the bottom left is what you call proton number. We know the number on the top left as part of the international standard. This is called the nucleon or the mass number. The bottom is proton number or atomic number. So we know that 105 is actually not nucleon, it's actually proton number. Okay, so A is out. Now, the atom there is an isotope of that. Well, we can see that 105 and 105 is the same, so same number of protons, done. 262 and 260, different number of neutrons. That's why you have different mass number or different nucleon number. B must be the correct answer. C must be wrong because of this thing called neutrons. It should be nucleons. D must be wrong because the 262 is incorrect. It should be 105 for the proton number. Okay. Number 4, actually this is the last thing we'll probably go through today. Which 2 molecules? Now this is the trickiest of all because so far you have only done for atom or ions. Now you're looking for molecules. How in the world do you work out the number of electrons in a molecule? If you have Cl2, you have 2 times chlorine atoms. So first of all, always work out the number of protons. Always work out the number of protons. In 1 chlorine, you have 17 protons. In 1 chlorine, you have 17 protons. You have 2 chlorine, so 17 plus 17, or you can do 17 times 2. Both of them will give you 34 protons. But then we can see this is molecule. Molecule is uncharged. Molecule has no charge. It is not ion. It is not ion. It is uncharged. If it is uncharged, then the total number of electrons, must be equal to the total number of protons. That is why we always work out the number of protons first, and then we can say, therefore, the number of electrons must be equal to 34 as well, because you have 34 protons there. The next thing is look at SO2. How many protons does sulfur has? Let me have a look at who is around. Afif, are you around?
Yes.
Afif, how many protons does sulfur has? You have a periodic table?
8. 16.
16. Be very careful, yeah? You are not reading relative atomic mass, you are reading protons. Okay, be very careful, atomic number. How many protons does oxygen have, Afika? Afika, are you there? I think it's probably lagging. Afika, how many protons does each oxygen atom have?
8.
8. And be careful, you have 2 oxygen. So you have 8 plus 8, or you can do 8 proton for 1 oxygen times 2. So altogether you get 16 plus 16, you get 32 protons. And because this is a molecule, so total number of protons is 32, so the total number of electrons is also 32, and they are not the same. You want the same. Okay, moving on to the next one, CH4. So how many protons does one carbon have, Marfua? Are you with me, Marfua? A little bit lagging?
Yes.
How many protons does one carbon have?
6.
6, and then this is 4 times 1, so this is 10, and then H2O, there is 1 times 2, there's 1 proton for 1 hydrogen atom, there are 2 hydrogens, and then there is 1 oxygen atom. Each one has a proton number of 8. We are looking at the number of protons. That is why it's very important to label. If we don't label, we will lose track, and we will be thinking about relative atomic mass, and that is where we will make a mistake. Okay, this will give me 10 as well. And guess what? When I get the answer, I can move on. All right, happy? So, I mean, that's it really for this topic. This topic has been pretty short. It's just been extended over a long period of time because of the SSRU exam. Now that you're finished, you have to review the topic yourself again. The textbook that you have been given is pretty good, except for the part on relative atomic mass calculation. That one you have to rely on the extract from the new textbook, which I shared with you very recently. Okay, but I mean, it's a mathematical skill, so as long as you're okay with that, I think should be all right. In terms of definitions, I think some people forget about this. You got to compare to 1/12 of the mass of an atom of carbon-12. Either that, or you got to mention something about expressed on the carbon-12 scale, somewhere along that line. But the 1/12 is really, really important. I think one of you defined it until here. If I'm not mistaken, there was Shaira who actually defined it as average mass of the isotopes, and then she did not use this comparison or the relative to 1/12 the mass of an atom of carbon-12. So this one is candidate should be able to describe completely. Okay, you cannot just stop halfway there. I think that's pretty much it. I don't know. Is there any question you want me to go through, like at all in your work 3? Is there anything in work 3 you want me to go through? Anything you don't understand at all? We might as well just go through it for like 5 minutes. I mean, definition wise should be all right, I guess. I mean, it's just full definition, right? Was there anything at all you want me to go through in this work that I've just returned to you? I mean, I put it back in your folder, so you can have a look at that. This one is a really, really, really badly done question. The other question were fine. This one was very badly done. Perhaps I should go through this. Okay. As with any questions, you will see that I scribble all over the place on the question itself. In a real exam, you have actually, let's have a look at the maximum mark. 10 marks. 10 marks mean 10 minutes. 10 minutes means you need to spend 10 minutes, including reading and interpreting information. No charge, charge. No charge is atom, charge is ion. Positive charge means that they are cation, positive charge. That is a result of atom losing 1 electron. That is a result of atom losing 2 electrons. Negative charge, anion. Atom gain 3 electron, atom gain 1 electron, and so on and so forth. Okay. I think Africa didn't do very well for this, if I'm not mistaken, or could be someone else. These are atoms. So when you pick an answer, if you choose an ion, you get 0 straight away. Okay. Noble gases. Noble gases such as helium. If you think about helium, is 2, neon is 2,8, argon is 2,8,8 from your periodic table, right? This one is completely filled outer shell, but it doesn't have 8 electrons in the outer shell. Be very careful. Not all the noble gases have 8 electrons in the outer shell, but all of them have a fully filled outer shell. Okay, these are noble gases, so be very careful. The next one I want to talk about is group 1. Okay, we know about group 1. Group 1 are metals. Metals will lose 1 electrons in order to, get to a fully filled outer shell. So when you have a group 1 element, they will give you a +1 ions because it's easy for them to lose 1 electrons in the outer shell. Rather than them gaining 7 electrons, metal will lose electrons. Metals will form positive ions. Positive ions come from metals. Negative ions come from non-metal. Okay, so I hope that makes sense there. The same thing with the group 5 elements. So they come from a non-metal having gained 3 electrons because 5 valence electron, group 5 valence electron, plus 3 give you 8. You will learn more about bonding eventually, so not to worry, C and E or C and G will be okay. As long as you have the charge cancel out, plus 1 and minus 2, plus 1 and minus 2, where is minus 2? Let's say C and G. So C and G, plus 2 and minus 1, or what was the other one? C and E. Plus 2 and minus 1. So plus 2 and minus 1, that will give you an XY2 combination. They don't mention what is X, they don't mention what is Y. So either could be accepted because the charge in a compound, the positive charge will cancel out the negative charge depending on how many of the ions you have. I'll tell you which one was the worst done question. This one was really badly done. All of you have the correct idea. But what you don't have correctly done was the explanation. All of you pick up the point where you say second shell is not fully filled. Yes, second shell is not fully filled. 1, 2, 3, 4, 5, 6. But if you look at all the second period elements, none of the second period elements have a completely filled out the shell except for neon. So, you know, they say, sorry? I think someone has just, someone hasn't muted themselves. So be careful of what you're saying, you know, on the air where people can hear you. All right. So yeah, I mean, you gotta fully fill the second shell before filling in the third shell. So your problem was you did not mention that this one is already filling in the third shell before fully filling up the second shell. So all of you mentioned second shell is not fully filled. But I can also say all the second period elements except for neon doesn't have a fully filled second shell, and there's nothing wrong with it. Okay, so make sure you focus on what is wrong. The third shell, it was filled before you fill up the second shell completely. I think this one was also quite badly done. This one was all right, surprisingly. So people know that ion is to do with electrons. Protons is not equal to the number of electrons, especially when you have ion. Okay, so this one is ion number G. Some of you put down hydrogen, but you didn't draw the sign of the charge because you didn't look at the symbol ion there. So for G, G is formed by gaining one electron. You gain 1 electrons, now you have 2 electrons. If you have 2 electrons, okay, you have 2 electrons, but what is your proton? Your proton number remains 1. You have 1 extra electron, that proton, that's why you are minus 1. Your proton is 1, that's why you are hydrogen, but you are an ion with a minus 1 charge. So be very careful about interpreting data there. I think I just leave it there for today. So like I said, 15 to 20 minutes lesson. Yeah, we just call it a day here. Unless people have questions, feel free to text me and then I will try and help you. But otherwise, the work has been returned to you and you are supposed to go through corrections on your own. And one thing, please don't share the work with the other class because the other class hasn't really done this work yet. They did the MCQ before you guys. Okay, so you won't be helping them by sharing the work. You can, of course, show them how to do it, but if they ask you how to do the whole paper, then you know something is wrong with them already. Okay, so I'll stop sharing here and we'll just call it a day here. So if you got a question, just text me directly and I'll try and help you. Okay, have a good day, guys.